So the heart of linear algebra is a way by which we can solve system of linear equations. So for example, consider x1 plus x2 plus x3, let's say it's equal to 8, and 2x1 plus 5x2 minus 3x3 is equal to 1, and 7x1 minus x2 minus x3, let's say this is equal to minus 1. So the objective is to find x1, x2 and x3 that will make each of the above equations true. So some of you might have already started using your vectors knowledge from your last unit to see that each row or equation is a dot product between scalars and unknowns, right? So the first equation can be written as r1 dot x is equal to 8, where r1 is equal to 1 1 1 and x is equal to x1 x2 x3. All right, and likewise, r2, the second equation can be written as r2 dot x is equal to 1, where r2 is equal to 2 5 minus 3 and x is same as x is equal to x1 x2 x3. And the third equation can be written as r3 dot x is equal to minus 1, where r3 is equal to 7 minus 1 minus 1, and again x is this guy. So in fact, later on in this unit we will also see that the above system of equations can be represented by a single compact equation of the form ax is equal to b. All right, where a will be equal to the coefficients of x1 x2 x3 in the equations. So a will be equal to 1 1 1 1 1 1, and then 2 5 minus 3 2 5 minus 3, and 7 minus 1 minus 1 7 minus 1 minus 1 into x, which is x1 x2 x3, is equal to the scalars on the RHS, that is 8 1 minus 1. And this, if you take a look at this equation, right, this kind of looks like a simple algebra equation that you might have learned in school, and this can be solved just like you would solve a normal algebra equation, right? That is by multiplying A inverse on both LHS and RHS. So in order to solve this equation, you are going to multiply A inverse on both the sides. So A inverse into AX is equal to A inverse into B, right? And this will result into x is equal to A inverse B. So, and of course this A inverse is special, so since this is the inverse of this matrix here. So later on in this course we will study what the matrix inverse is and what are the constraints around the said multiplications later on. But anyways, hope I have whetted your appetite for learning matrices, and I'll see you in the next lecture.